So let's practice your organic chemistry skills and predict the product of each nucleophilic acyl substitution reaction. So here are the answers. I hope you got them right. Nylon is made by reacting an acid plus an amine to make an amide. Note that there are many types of nylons which have many different uses. Let's take a look at how nylon is made in more detail, so stop the video and answer these questions. So in this reaction, an amine reacts with an acid to form an amide functional group. This is called the condensation reaction because water is another product. And to use curved arrows to form this tetrahedral intermediate, and note that the leaving group, which needs to be made into a better leaving group, is this one, and that'll form the product. Adipoyl chloride is usually used to make nylon instead of adipic acid because the reaction is faster. Why do you think the reaction is faster with adipoyl chloride rather than adipic acid? Turns out that an acyl chloride is more reactive than an acid. And the leaving group when adipoyl chloride is used is the chlorine. So amino acids undergo nucleophilic acyl substitution reactions to form proteins. So apply your organic chemistry skills to show how glycine and alanine react to form a peptide. And the product of this reaction is, note that two possible products can form. In one case, this acid group reacts with the amine to form this product. In the other case, this acid group reacts with that amine to form this product. So we know that an acid reacts with an amine to form an amide. The reverse of this reaction is the hydrolysis of the amide to form an acid plus amine. So that's one way that our body metabolizes chemicals. So when melatonin metabolizes in our body, one product is acetic acid. Stop the video and draw the structure of the other product. And the answer is, so remember that the amide is formed from an acid and an amine. So I'm sure many of you work out. Did you know that eating watermelon may prevent muscle soreness due to the presence of citrulline? So stop the video and draw the metabolic products of citrulline. Here is the amide functional group, and this is the structure. Cyclic amides are called lactams, and beta-lactams are a common structural feature in antibiotics. Note that there are 3 acid or acid derivatives in this structure, so stop the video and answer the question, at which atom will nucleophilic acyl substitution occur? So here are the 3 acid or acid derivatives, and the acyl substitution reaction will occur at, so although amides are the most stable of the acid derivatives, remember that 4-sided ring has ring strain, so this lactam ring is the most reactive. So beta-lactam antibiotics work by deactivating a transpeptidase enzyme. So stop the video and draw the structure of the product of each of these reactions. So here are the answers. So the first reaction is an acid-base reaction. The sodium hydroxide base reacts with the acid group. In the hydrolysis reactions, note that the amide functional groups are converted to an amine and an acid functional groups. And the transpeptidase enzyme has an alcohol group, so note that the alcohol group undergoes electrophilic aromatic substitution at the beta-lactam ring. So deamidation is the process by which asparagine is converted to either isoaspartic acid or aspartic acid. So stop the video and apply your organic chemistry skills to show how this reaction occurs. So in the first reaction, note that the lone pairs on this nitrogen undergo acyl substitution at this carbonyl carbon to form that succinimide intermediate. And then think of the succinimide intermediate as 2 amides. So in one case, this amide functional group undergoes hydrolysis to form the aspartic acid. And then in the other reaction, think of this as a amide functional group to form isoaspartic acid. Luciferin is a bioluminescent compound that causes earthworms to glow. So stop the video and draw the structures of the products of luciferin hydrolysis. So note that there's 3 amide functional groups. And here are the products. So remember, practice makes perfect.